In this video, we shall discuss a problem that illustrates the effects of electric force versus the effects of gravitational force on a point particle such as a proton. So let's get to the problem. A proton is in a region of vertically upward electric field with magnitude 3000 volts per meter, as shown in this diagram. Compare the electric force and gravitational force on the proton. So let's do this part first. If we were to sketch a free body diagram of this proton, we know there are two forces acting on this proton. One force is the electric force. Let's denote it as F sub E. The other one is its weight due to its mass. Let's call it F sub G. We want to examine the magnitude of the electric force versus the gravitational force. So let's calculate the magnitude of the electric force. The direction of the electric force is upward. Because proton has a positive charge, the electric field is going upward, so that is also the direction of this electric force, because it's given as a product of the charge of the proton times the electric field. So since force is a vector, because electric field is a vector, the direction of this electric force is the same as the direction of the electric field, because charge here is a positive charge. The charge of proton is given by that number, so it is 1.6021 times 10 to the power minus 19 coulomb. The magnitude of the electric field is 3000 volts per meter. And that's going to give you an answer of 4.81 times 10 to the power minus 16 newtons. Now let's calculate the gravitational force on that proton, namely its weight. That is given by the mass of the proton times gravitational acceleration. The mass of the proton is given to be that 1.6726 times 10 to the power minus 27 kilograms. G is 9.81, which will give you an answer of 1.64 times 10 to the power minus 26 newtons. What that means is, from these two numbers, we can draw the following conclusion. The electric force is about 2.9 times 10 to the power 10 times larger than the gravitational force. So that shows the gravitational force is extremely small in comparison to the electrical force, that we can neglect the proton's weight in the rest of the problem. Now let's look at the rest of the problem. Now assume the proton is released from rest at the lower plate. There. What speed it acquires as it reaches the upper plate, a distance 1 centimeter away? As we have pointed out earlier, the gravitational force can be neglected in comparison to the electric force. We also see the electric force is a constant. That means the acceleration is a constant, and we can use kinematics to solve this problem. We are given the initial speed. So the initial speed of the proton is 0. It is released from rest. We know the distance it travels, so let's call it delta y. It's 1 cm, or 1 times 10 to the power minus 2 meter. The acceleration can be calculated by simply taking the force, 4.81 times 10 to the power minus 16, and dividing that by the mass of the proton, which is 1.6726 times 10 to the power minus 27. And that's going to give you an acceleration of 2.88 times 10 to the power 11 meter per second squared. We want to determine the speed of the proton as it gets to the upper plate. Let's call that speed v. There is an equation kinematics that enables you to calculate v, and that is v squared equals u squared plus 2 times the acceleration times the distance traveled. U is 0, as indicated there. So v is quite simply the square root of 2 times acceleration, which is that number, 2.88 times 10 to the power 11, and the distance traveled is given by 1 cm. Convert that into meter, so that means 10 to the power minus 2 meter, and take the square root of the entire product. And you will get an answer of 7.6 times 10 to the power 4 meter per second. What about the time it takes to travel this distance? Since we know the final speed, the initial speed, the acceleration, the time can be calculated by using another kinematics equation, namely v equals to u plus at. Since the initial speed, or u, is 0, the equation becomes that, and time of travel is simply v divided by a. V is 7.6 times 10 to the power 4. A is that number, 2.88 times 10 to the power 11. And the answer should be in seconds. And that's going to give you an answer of about 2.6 times 10 to the power minus 7 seconds. So this is the amount of time the proton takes to travel from the bottom plate to the upper plate. And that solves the problem. Thank you for watching.